Hi, welcome to xmTuition, where I help everyone with their physics homework. Like yesterday at the playground, this little girl asked me to explain this question to her. So this question is about SHM. During which of these four instances is the oscillation having velocity and acceleration in the same direction? I'll show you two different approaches to this question. Let's just figure out the direction of the accelerations and velocities directly. So what is given is the displacement. How do we link the direction of displacement to the direction of acceleration? Easy. They are always opposite in directions. So what is the acceleration here? 0. Because the displacement is 0, acceleration is also 0. What is the acceleration here? Negative. Because we have a positive displacement here, so the acceleration has got to be negative. What about here? Displacement is negative, so acceleration must be positive. And it's the same thing here. Now let's move on to the velocity. Given the displacement time graph, how do you figure out the velocity? Easy. The velocity is just the gradient of the displacement time graph. Positive gradient here, so velocity must be positive. 0 gradient here, so velocity must be 0. Negative gradient here, so velocity is negative. Positive gradient again, so velocity is positive. So which of these 4 points do we have acceleration and velocity in the same direction? Actually, right at the beginning, we could have ruled out option A and option B, because option A has acceleration of 0. There's no direction to talk about. And option B, velocity is 0. So the velocity has no direction at points B. So actually the answers cannot be at the equilibrium position or at the extreme positions. Let's look at C and D. Here, the acceleration is directed upward towards the equilibrium position. The velocity is directed downward. The oscillation is still moving away from the equilibrium position. Whereas at point D, the acceleration is towards the equilibrium position, so upward, and the velocity is also upward because it's traveling towards the equilibrium position. So that's the first approach. The second approach would be just to sketch all the graphs for displacement, velocity, and acceleration. So what's given is the displacement time graph, which is a negative cosine graph. That means displacement is negative x0 cosine omega t. If we differentiate this with respect to time, what do we get? The velocity time graph, isn't it? When you differentiate a cosine function, you get negative sign, right? So with a negative here, is back to positive sine omega t. So we now know the velocity time graph is a sine function. So how do we get the acceleration function? Just differentiate the velocity function. So from here we get omega x squared naught cosine omega t. So we know the acceleration time graph is a cosine function. So at point C, your acceleration is positive, but your velocity is negative. At point D, your acceleration is positive, and your velocity is also positive. That's why the answer is D. I hope this little girl will continue to study physics. I think she's very talented. Ta-ta!